Okay, Algebra Honors 3-4 students, welcome to R.5, Rational Expressions. This part of it is going to focus on adding and subtracting rational expressions. To do this, you want to factor out the denominator. Again, it might already be factored for you. Find the common denominator. If the common denominator is already there, you don't have to do that step. Combine the numerator and simplify, okay? I want you to write this down. These are the steps. And we're going to try some examples here, all right? Adding and subtracting is fun. Adding and subtracting rational expressions is a good time. Let's try a couple examples. Let's try 5 over 9x squared plus 1 over 6x. Okay. So this one's kind of already factored. I mean, I could break down the 9 to 3 and 3 if I really wanted to. I think from here we can see how to make them common denominators. If you look at 9 and 6, what's the smallest number that both 9 and 6 go into evenly? And that's going to be our common denominator's coefficient. That number is 18. Let's see, what could I multiply 9 by to get to 18 in the denominator? 2, right? So what I'm going to multiply by is 2 over 2. So that would give me a coefficient of 18. How come I'm allowed to just go around and multiply by 2 over 2? What is 2 over 2 equal to? 2 over 2 is 1. And when you multiply something by 1, you're not changing the value of what that expression is. You're just changing the way it looks a little bit so that we can, add these fractions together. What can I multiply 6 by to give me that common denominator of 18? Well, the 6 is going to need to be multiplied by 3. So I'm going to multiply by 3 over 3, right? So we're almost got our common denominator. The only thing that this one is missing is an x. So I'm also going to multiply by x over x. Okay, so I'm going to clean this up a little bit, and I get 10 over 18x squared plus 3x over 18x squared. Now I've got my common denominator. And when you add fractions, just like you did when you were in 3rd grade, the denominator stays the same, and we got 18x squared on the bottom. We combine the numerators, 10 plus 3x. All right, let's try another one. I'm going to erase this. I've got y over y minus 2. And then let's add 8 over 2 minus y. Okay. So I need to make these two denominators look the same, right? We've seen this before. Look, we have a positive 2, here we have a negative 2. We have a negative y, here we have a positive y. I need them to look the same. What can I multiply this by so that it looks exactly the same as that? How about negative 1? I'm going to multiply the bottom by negative 1, but I can't just go around multiplying the bottom by negative 1. I have to multiply the top by negative 1. That way I'm multiplying by a fancy version of 1. That keeps it equal, it keeps it to the same value, it just changes the way it looks. So I have y over y minus 2 here, nothing changed, plus negative 1 times 8 is negative 8, and negative 1 times 2 minus y. 2 turns into a negative 2, a negative y turns to a positive y, and I get y minus 2. Now I have my common denominator that can stay the same. I have y minus 2. On the top I have y minus 8. Can I cancel the y's? No, I cannot. Can I simplify 8 over 2? No, I cannot. All right. Are you ready to take it up to the next spice level? Let's take it up a couple spice levels. Let's take it all the way up to spice level 8. Here we go. Let's take a look at, I'm stealing this one from the book, it's a good one. 3x over x squared plus x minus 12. And then let's do minus x over x squared minus 16. Okay, so for this one, it's hard to see what the factors are in this denominator that this one has, and the factors that are in this denominator that this one has in its current format. We're going to need to factor the denominator so we can see them in the factored form. Will easily allow us to see which factors the other denominators need. So I'm going to take, well, this here, I have a trinomial, it's quadratic, and the leading coefficient of 1. That's magic numbers. What multiplies to negative 12 and adds to 1? I believe that's positive 4 and negative 3. So we get 3x, and on the bottom, I have x plus 4 and x minus 3. And then minus, let's see here, I have x, and look at this is difference of squares. That's an easy type of factoring, right? It's going to factor to two binomials, and let's see, the square root of x squared is x, so x for the first term for both of those factors, and the square root of 16 is 4, so x plus 4 and x minus 4. Okay. All right, now look, I have a denominator, boom, boom. Plus 4 minus 3. What does this one have that this one does not have? It looks like it needs an x minus 4, so I'm going to multiply by x minus 4 on top, on bottom, and x minus 4 on top. So I multiply by 1, and now I have 3 factors here. I have 2 factors here. I have the plus 4 and the minus 4. It looks like it needs the x minus 3. So I'm going to multiply by x minus 3 over x minus 3. All right, now we're getting to be in business. Let's see, I have a 3x squared, and I'm going to distribute that to here, because look, I've got common denominators, guys. Now I just need to combine the numerators, and we're home free. But before I can combine, I have to distribute first, right? I was going to distribute before we add. So 3x squared times x gives me, 3x times x gives me 3x squared, and 3x times negative 4 is negative 12. Now careful here, because you're subtracting, so really, you're really distributing a negative x here, right? So negative x times x is negative x squared, and negative x times negative 3 is plus 3x, okay? And we've got our common denominator of x plus 4, x minus 4, x minus 3. All right, now I just have to combine these. Let's see, I have 3x squared minus x squared, so that's equal to 2x squared. And I have negative 12, oh my goodness, all the way back to here. When I distributed the 3x to the negative 4, I put negative 12, I forgot the x, I'm so sorry guys, I do apologize. So I got that x there. So I have negative 12x plus 3x, which is minus 9x, okay? And then on the bottom, I have x plus 4, x minus 4, and then x minus 3. Now the last thing we want to check is if this can be factored, this numerator here, maybe something can cancel. So we always want to try to factor. Well, really the only thing I can factor in that numerator, I can pull out an x, and if I do, I get x, and then I get 2x minus 9 over x plus 4, x minus 4, and x minus 3. I love it. That's a tough one, right? Spice level 7. Spice level 8, I apologize. We really took it up a notch. You might not appreciate the beauty, but I love it. It's unorganized chaos, I suppose. I don't know, but I think it's great. Look, we went from there to there. Long story short, make common denominators, combine the numerators, simplify. Thank you so much. We've got one more R.5 lesson coming up.